हेलो स्टूडेंट्स, आई एम किशन कुमार। वेलकम टू माय यूट्यूब चैनल के मैथमेटिक्स। यहाँ पर मैं बीएससी स्टूडेंट्स के लिए सिलेबस बेस्ड वीडियोस अपलोड करता हूँ। अगर आप बीएससी कर रहे हैं या किसी भी कॉम्पिटिटिव एग्जाम की तैयारी कर रहे हैं और चाहते हैं विद इन सम मिनट्स आपका जो मैथ का कंसेप्ट हो जाए क्रिस्टल क्लियर, तो जुड़े रहिए मेरे यूट्यूब चैनल के मैथमेटिक्स के साथ। आज का जो टॉपिक है सॉपरिंग्स। प्रीवियस लेक्चर में हमने पढ़ा था व्हाट इज रिंग एंड इट्स प्रॉपर्टीज। तो अगर अभी तक आपने वो वीडियोस नहीं देखा है तो ऊपर आइटम में जाकर देख सकते हैं। तो हियर लेट आर इज ए रिंग अंडर द बाइनरी ऑपरेशन एडिशन एंड मल्टीप्लिकेशन, देन a subset of R S is called a subring of R if S itself form a ring with respect to the same operation defined on R, or equivalently S is a subring of R if it satisfies the following condition: S is closed under addition and multiplication, that is A plus B belongs to S and A into B belongs to S for all A and B belongs to S, and additive identity 0 is belongs to S, and in third property for every element belongs to S their additive inverse also belongs to S. and बाकी जो प्रॉपर्टी है associative under addition and associative under multiplication and distributive law, ये बाय डिफॉल्ट सेटिस्फाई करेगा क्योंकि यहाँ पर S का जो ऑपरेशन है ये रिंग के ऑपरेशन के साथ सेम है। फॉर एग्जाम्पल Z इज ए सबरिंग ऑफ Q, क्योंकि यहाँ पर इंटीजर सेट जो होता है ये सबसेट होता है रैशनल नंबर सेट का, एंड यहाँ पर Z ऑल्सो रिंग होता है अंडर द ऑपरेशन एडिशन एंड मल्टीप्लिकेशन। सिमिलरली Q इज ए सबरिंग ऑफ R, क्योंकि यहाँ पर Q जो होता है ये सबसेट होता है R का, एंड Q ऑल्सो रिंग होता है अंडर द एडिशन एंड मल्टीप्लिकेशन। एंड हियर 2Z इज ए सबरिंग ऑफ Z, कि यहाँ पर 2Z जो होता है ये रिंग होता है अंडर एडिशन एंड मल्टीप्लिकेशन। नेक्स्ट जो है इन थ्योरम नंबर 1 व्हिच इज सबरिंग टेस्ट, let R be a ring and S be a non-empty subset of R, then S is a subring of R if and only if the following condition satisfied. That means A minus B belongs to S for all A and B belongs to S, and A into B belongs to S for all A and B belongs to S. That is closure under multiplication. To prove this necessary part, let assume S is a subring of R. That means S satisfy all the properties of ring under the same operation addition and multiplication. Since S is a subring of R, then if B belongs to S, then its additive inverse also belongs to S. That means minus B also belongs to S. And since S is also closed under addition, so for any A and B belongs to S, we can write minus B also belongs to S. So we can write A plus minus B belongs to S. That means A minus B belongs to S for all A and B belongs to S. And further, S is a subring, so it's also closed under multiplication. So here we have A into B belongs to S for all A and B belongs to S. And conversely, let assume these two properties are satisfied. That means for all A and B belongs to S, A minus B belongs to S and A into B belongs to S. Then by condition 1, A minus A also belongs to S. That means 0 belongs to S. So here additive identity belongs to S. And again 0 belongs to S and A belongs to S, then 0 minus A belongs to S by condition 1. So here minus A belongs to S. So here additive inverse also belongs to S. Similarly for A and B belongs to S, so here minus B also belongs to S. So यहाँ पर we can write by condition 1 A minus B belongs to S. So this is equal to A plus B belongs to S. तो यहाँ पर ये जो सबसेट एस है ये क्लोज्ड अंडर एडिशन एंड मल्टीप्लिकेशन है, एंड इसके अंदर एडिटिव आइडेंटिटी आल्सो एग्जिस्ट करता है एंड एडिटिव इनवर्स आल्सो एग्जिस्ट करता है। सो दिस इज ए सबरिंग ऑफ आर। तो इस टेस्ट को अप्लाई करके आप चेक कर सकते हैं कोई भी रिंग का सबसेट सबरिंग है कि नहीं। तो सिंपली हमें यही दो कंडीशन चेक करना है। अगर ये दो कंडीशन सेटिस्फाई करते हैं देन ये जो सबसेट है ये सबरिंग होगा। नेक्स्ट इसके ऊपर बेस्ड कुछ प्रॉब्लम सॉल्व करते हैं। इन प्रॉब्लम नंबर 1, so that the set S equal to set of all 2 cross 2 diagonal matrices which entries are integers is a subring of ring M2 over Z, which is set of 2 cross 2 matrix over Z. तो यहाँ पर देखो ये जो जीरो मैट्रिक्स होता है 2 cross 2 का, this is belongs to this S. So here this set S is non-empty, and to show this set S is a subring of this ring, we have to prove only two conditions. A minus B belongs to this set S and A into B belongs to this set S for all A and B belongs to S. तो यहाँ पर देखो let A equal to a diagonal matrix which is A0 and 0 B. Similarly, let B equal to a diagonal matrix C0 and 0D. So here A and B belongs to this set S. So here A minus B equal to subtraction of these two matrix. So this is equal to A minus C 0 0 B minus D. So this is also a 2 cross 2 diagonal matrix. So this is belongs to the set S. So here A minus B belongs to this set S. Similarly, here A into B जो होगा multiplication of A0 0B into the matrix C0 0D. So ये दोनों मैट्रिक्स का जो मल्टीप्लिकेशन होगा दिस इज इक्वल टू AC 0 0 BD. So this is also a 2 cross 2 diagonal matrix. So this is also belongs to this set S. So here A minus B belongs to S and A into B belongs to S. For all A and B belongs to S. So here by Subring test, S is a Subring of this ring F2 over Z. Next in problem number 2, let R be a ring, then show that the center of ring, which is set of element of R, which commute with all element of R, is a Subring of R. तो यहाँ पर देखो 0 जो है ये commute करेगा with the all element of R. So this 0 belongs to the center of R. So here Z of R is non-empty. And to prove this Z of R is a Subring of R, we have to show these two property, which is A minus B belongs to R and A into B belongs to R for all A and B belongs to R. So here let Z1 and Z2 belongs to this center of R. Then for all R belongs to this ring R. By definition of center of ring, we can write it as Z1 into R equal to R into Z1 and Z2 into R equal to R into Z2. So here we can write Z1 minus Z2 into R equal to Z1 into R minus Z2 into R by properties of ring. So this is equal to, यहाँ पर Z1 into R को हम ऐसे लिख सकते हैं R into Z1 minus Z2 into R को हम ऐसे लिख सकते हैं R into Z2. So again this is equal to R into Z1 minus Z2. तो यहाँ पर देखो Z1 minus Z2 into R equal to R into Z1 minus Z2 for all R belongs to R. That means यहाँ पर Z1 minus Z2 जो है ये commute कर रहा है all element of R के साथ. That means Z1 minus Z2 belongs to center of R. Similarly, we can write Z1 into Z2 into R equal to Z1 into Z2 into R by associative property. So this is equal to Z1 into, यहाँ पर Z2 into R को हम ऐसे लिख सकते हैं R into Z2. So this is equal to Z1 into R into Z2. Again यहाँ पर Z1 into R को हम ऐसे लिख सकते हैं R into Z1 by definition of center of ring into Z2. So this is equal to R into Z1 into Z2. तो यहाँ पर देखो Z1 into Z2 into R equal to R into Z1 into Z2. तो यहाँ पर Z1 into Z2 जो है commute कर रहा है R के साथ for all R belongs to R. So here Z1 into Z2 belongs to the center of R. तो यहाँ पर Z1 minus Z2 belongs to Z of R and Z1 into Z2 belongs to Z of R for all A Z1 and Z2 belongs to Z of R. So by Subring test, center of ring is a Subring. Next in problem number 3, show that the intersection of two Subring of a ring R is a Subring of R. To show this, यहाँ पर let assume कर लेते हैं S1 and S2 are two Subring of R. Since S1 and S2 are two Subring of R, so here 0 belongs to the S1 and also 0 belongs to S2. So here 0 belongs to S1 intersection S2. So here S1 intersection S2 is non-empty. So यहाँ पर let arbitrarily assume कर लेते हैं let A and B belongs to this set S1 intersection S2. That means A and B belongs to S1 and A and B belongs to S2. And here since S1 and S2 are Subring, so here a minus b belongs to S1 and a minus b belongs to S2. That implies a minus b belongs to S1 intersection S2. Similarly, since S1 and S2 are Subring, so here a into b belongs to S1 and a into b belongs to S2. That implies a into b belongs to S1 intersection S2. So here, since a and b are arbitrary, so here a minus b belongs to S1 intersection S2 and a into b belongs to S1 intersection S2 for all a and b belongs to S1 intersection S2. So here by Subring test, this S1 intersection S2 is a Subring of R. So here intersection of two Subrings of a ring R is a Subring of R. आई होप ये जो सॉल्विंग का कंसेप्ट है आपको समझ में आ गया होगा। अगर आपको वीडियो अच्छा लगा तो लाइक शेयर एंड सब्सक्राइब करना मत भूलना।